In each of the following balanced oxidation reduction equations, identify those elements that undergo changes in oxidation number. Indicate the magnitude of the change in each case. All right, so with diiodine tetraoxide going to iodine, right? Again, there's like 6 rules we used in Chapter 4 to assign oxidation state. One of the rules was oxygen is almost always -2. So each of those oxygens in diiodine pentaoxide would be -2. So therefore, each of the iodines would have to be +5 in order for it to be a neutral compound. That was another rule, right? They have to add up to be the charge on the species. So with carbon monoxide, right, the oxygen being -2, therefore the carbon has to be +2. Elements are always 0, so iodine is 0. And the carbon in carbon dioxide would have to be +4. So this is how we do it. Looking at the next one, you're going from mercury 2 to mercury elemental, which would be 0. And each of the nitrogens in dinitrogen tetrahydride would be -2. And again, nitrogen is going to elemental nitrogen, which would be 0. Dihydrogen sulfide, sulfur is going to 0, so the sulfur in dihydrogen sulfide would be -2. And we've got, there it is, nitrate, right? And in nitrate, the nitrogen must be +5, and in nitrogen monoxide, it would have to be +2. Again, so the rules are, right, the sum of the oxidation states has to equal the charge on the species. So this is why the nitrogen in nitrate has to be +5. Each of the oxygens would be -2. That's another rule. If you're element, you're 0. Barium 2+. Going to barium 2+, so that's not a change there, right? Barium 2 chlorite. There it is, right? So here's an exception, right? Oxygen is almost always -2, except in peroxide. In this case, it's going to be -1, since each of the hydrogens would have to be +1. And we've got the chlorine and chlorine dioxide going to from a +4 to a +3 charge in chlorite. Oxygen going from a -1 to a 0. So again, those rules, got to know the rules. About 6 rules you have to know in terms of assigning oxidation state. All right, complete and balance the following equations and identify the oxidizing and reducing agents. All right, when we have, earlier in the course, right, when we were balancing, we balanced by inspection, right? We could try different combinations of coefficients to try to balance. But with redox reactions, they're just too complicated to do it by inspection. So the first thing we have to figure out is whether we're dealing with an acidic solution or a basic solution, and then there's a set of rules we'll use for balancing in an acidic solution or a basic solution. All right, so the half reaction method, right? You write the unbalanced equation in ionic form, omitting spectator ions. Separate the equation into half reactions, right? There's an oxidation half reaction, and a reduction half reaction. Balance each half reaction except for O and H. In acidic solution, balance the O's by adding waters, and balance the H's by adding H pluses. 6, balance the charge of the half reaction by adding electrons, right? So we want the charge on each side of the half reaction to be the same. Multiply the half reactions by some sort of integer, so the same number of electrons are going into the reaction as coming out. And then you add the half reactions back together, canceling anything that's redundant, right? Anything that appears the same on both sides. Check to make sure that the atoms bounce. That'd be in an acid. If you're balancing in a base, you just pretend like you're in an acid, and then at the end get rid of any H pluses by adding hydroxides to both sides. Hydroxide plus H plus is water. So cancel any extra waters, and you've balanced in a base. So let's watch it in action, right? So if we've got A, dichromate reacting with iodide to make chromium 3 plus and iodate, we split it up into 2 half reactions. Iodide turning into iodate and dichromate turning into chromium 3 plus. We follow the rules, right? So I think I started with the top one. Or did I start with the bottom one? I started with the bottom one. Bottom half reaction. Doesn't matter which half reaction you pick, right? You just start following the rules. All right, so rule number 2 was, after we've broken everything up into 2 half reactions, balance everything except for O and H. So I've got 2 chromiums going in, I need 2 chromiums coming out. Balance the O's by adding waters. So if I have 7 oxygens in the molecule, I have to add 7 waters to the other side to balance the O's. That introduces 7 waters is 14 H's. So I balance the H's by adding H pluses to the other side. Balance the charge by adding electrons, right? So 2 times 3 plus is a plus 6 charge on the one side, and you've got a plus 14 and a negative 2, so that's plus 12 on this side. So if I add 6 electrons to the reactant side, I now have a plus 6 charge on each side of the equation. And I have followed the steps for balancing this half reaction. Now I go to the other half reaction, right? I've got same iodide, right? So that's nothing to do there. I've got 3 oxygens on the product side, so I'd have to add 3 waters to the reactant side. I've now introduced 6 hydrogens, so I'd add 6 H pluses to the product side. And balance the charge. So I've got a plus 5 charge and a minus 1 charge. So if I add 6 electrons to the product side, I now have minus 1 on both sides of the equation. All right, the last bit, I look to see if the electrons going in are the same as coming out. They are, so there's nothing to do there with balancing. And now I add the half reactions back together, canceling anything that's redundant. So the electron should always cancel when you're doing the half reaction method. So 6 electrons going in, 6 electrons coming out. I now have a redundancy here of 6 H pluses, right? I have 14 going in and 6 coming out, so I can get rid of 6 of those H's. And I've got 3 waters going in and 7 coming out, so I can get rid of 3 of those waters. Add the half reactions back together. Oh, I forgot to cross out the H pluses. So 6 H pluses, no, minus 6 H pluses from 14 gives you 8 H pluses going in, 1 iodide, 1 dichromate, 2 iodates coming out, 2 chromium 3 pluses, and 4 waters. I can see here that everything balances. There we are, right? 7 waters, 7 oxygens, it's balanced. All right, C. We split up into two half reactions, right? Iodine turning into iodate and hypochlorite turning into chloride. We balance everything except for O and H in the... I'm sorry, working with the second half reaction here. So the chlorines are balanced. We add a water to the product side to balance the O's. We add 2 H pluses to the reactant side to balance the H's. We add 2 electrons to the reactant side to balance the charge. So I've got a -1 charge on each side of the half reaction. Again, it's just following the steps. So balance everything except for O and H. So I need to put a 2 in front of the iodate to get 2 iodines going in and coming out. I need 6 waters added to the reactant side to balance the O's, 12 H pluses to balance the H's. The charge on the product side is plus 10, so I'd have to add 10 electrons to the product side to get a neutral on either side, no charge. All right, now I've got 2 electrons going in, 10 coming out, so I multiply the second half reaction by 5. So I get 10 electrons going in, and I balance, I multiply everything else by 5. 10 electrons coming out, so when I add these half reactions together, the electrons cancel, and I've got 10 redundant H pluses and 5 redundant waters. So when I add everything together, canceling anything that's redundant, I get the balanced equation. D, same thing, right? Split up into 2 half reactions. Balance everything except for O and H. Balance the O's adding waters. Balance the H's adding H pluses. Balance the charge by adding electrons. Again, so there's no charge on the product side. So if I add 4 electrons to the reactant side, 6 H pluses and 6 negatives cancel. I go up to the first half reaction, I've got 2 AS's going in, so arsenic's going in, so put a 2 in front of the, what is that, arsenic acid, and balance the O's adding waters, balance the H's adding H pluses, and balance the charge by adding electrons. 4 electrons going in, 4 electrons coming out, so no need to multiply by some coefficient. Just add it together, canceling anything that's redundant. 4 of those H pluses cancel, 3 of those waters cancel, and when I add it together I get the balanced equation. Now with E I'm in a basic solution, so I just pretend like I'm in an acid, right? Break it into half reactions, balance everything except for O and H, balance the O's by adding waters, balance the H's adding H pluses, balance the charge by adding electrons. 3 electrons going in, 6 coming out, so multiply the top half reaction by 2. So 6 electrons going in, 6 electrons coming out. Canceling anything that's redundant when I add it together. And now I've got the extra step. I've got 2 H pluses going into this reaction, so if I'm in a basic solution, add enough hydroxide to both sides of the equation to get rid of those 2 H pluses. So 2 H pluses and 2 AOH minuses equals 2 waters. So I've got 2 extra waters to cancel, and no, I'm sorry, I've got 1 water to cancel, and I end up with the balanced equation in a basic solution. I've got an extra one here. All right, so another basic one. So split it up into 2 half reactions. Balance everything except for O and H. Balance the O's adding waters. Balance the H's adding H pluses. Balance the charge by adding electrons. Multiply by a coefficient of the same number of electrons going in as coming out. Add the half reactions together. And oh, there are no H pluses when I add this together, right? So I cancel my 8 H pluses going in, H pluses coming out. So that's it. You know, there is no hydroxide to add to this because there's no H pluses. So this would be balanced as though it were in a base. Balance as though it was in a basic solution.